How to construct the Great Unification Theory, attempts made by scientists. 4. In the previous issue, quantum mechanics ultimately integrated three of the four natural forces: electromagnetic force, strong nuclear force, and weak nuclear force, but it has never been able to tame universal gravitation, which has become the ultimate challenge in physics. In 1976, three physicists at State University of New York at Stony Brook wrote the theory of supergravity. They found that in an 11-dimensional metric tensor model, almost all particles and forces in nature are included: Einstein's theory of gravity, Yang-Mills fields, and Maxwell fields, as well as quarks and leptons. The theory of supergravity suggests that the 11-dimensional metric tensor field can be simplified into 4 dimensions, which is Einstein's gravity field. By increasing its dimensionality, we can derive the Maxwell equation system and standardized model. Finally, in the 11th dimension, all the equations representing the 4 forces were unified. Although the theory of supergravity integrates 4 forces in its model, it has limitations. There are no specific quantitative mathematical models and formulas at many key nodes. The birth of string theory originated from an accident. In 1968, 2 young theoretical physicists in Europe unexpectedly discovered that Euler's formula could explain the strong interaction forces between elementary particles. Later, American physicist Leonard Susskind further understood the Euler's formula as a small elastic band that could be twisted, and this theory gradually developed into the string theory. This theory holds that matter is composed of strings, which are one-dimensional objects without mass and are the smallest units. Strings can be stretched, expanded, or rotated. It can be interconnected and closed, or it can be disconnected and split. Various forces are generated between strings by exchanging strings, thereby unifying the 4 natural forces, including gravity. From this perspective, the universe is like a musical instrument. Just as the vibration of the same string on an instrument will produce different tones or frequencies, and different string vibration modes will produce fundamental particles with different properties. Our real material world is actually a magnificent symphony, played by cosmic strings, with a large amount of data stored through the strings. With in-depth research on superstring theory, scientists believe that closed strings aggregate to form membranous substances. The universe we exist in may be a membrane floating in high-dimensional space. So what is the highest dimension of the universe? The one who unraveled this secret was another mathematical genius, Lamanukan, who proved mathematically that string theory is only self-consistent in 10 dimensions. That is to say, the high-dimensional universe that gave birth to our existing universe must have 10 dimensions. In 1994, Edward Witten proposed the M-theory, which aimed to unify different superstring theories and form a unified theoretical framework. He believes that our universe is 11 dimensions because only in this way can we unify all 5 superstring theories, and therefore M-theory is known as the ultimate theory of physics. It is worth mentioning that string theory and M-theory have not yet been experimentally confirmed, and the existing large particle colliders in humans are no longer able to complete the experimental proof required for string theory. Next issue, let's talk about physical experiments that scientists cannot explain.